This is the video for section 1.1, skills and practice. So the first part asks us to write a verbal expression for each algebraic expression. So we're going to go into English from a math expression. So the first one, we have 9a squared. So we could write that as the product of 9 and a squared. Remember, product means multiplication, and when two numbers are next to each other, or a number and a variable in this case, that means multiplication. So if we move on to number 2, we have 5 to the second power, which, if we remember, the second power is a special one in math, and we call that squared. So this is simply 5 squared. The next one, we have c plus 2d, and when we see a plus, we can call that a sum. So one way that we could write number 3 would be to say that c plus 2 times d, or we could use the sum idea and we could say the sum of c and twice d. And twice means 2 times. Number 4, we have a minus sign, and just like we can use the sum, we can use the difference for that. So we could say the difference of, and remember, when you say the difference, the order matters. So we need to have 4 first, so because it shows up first in the math sentence. The difference of 4 and 5 times h. Next one, we have twice b squared, 2 times b squared. So we could say twice or double b squared. We could do it as exactly as it's written, and we could say 2 times b squared. The next one, we have 7x cubed minus 1. So we could call this a difference, or we could say 7 times x cubed. I might have misspoke back there. That's x cubed decreased. That means minus. Decreased by 1. Number 7, we have, again, a plus addition, so we can use the sum. We could use plus, just like we did in 3. I'm going to, in this case, use the sum. So I'm going to say the sum of p, and there's no special name for the 4th power, so we are just going to say p to the 4th power and 6 times r. And this one down here, we could go with the difference. We could go with 3 times n squared minus x. We could go like we did with number 6 and say 3 times n squared decreased by x. I think I'm going to choose to just write it like it's written. So I'm going to say 3 times n squared minus x. So I hope what you're getting out of this is that when you're writing from a math sentence into words, there's a couple of different ways you can do it every time. And there's not one that's more right than the other. The problem that you might run into is that it gets a little confusing. So you want to make sure that you reread what you've written and it makes sense and it says what you want it to. So let's move on to the next part. In the next part, we go the opposite direction. It says write an algebraic expression for each verbal expression. And this is a little bit easier in my opinion. I like this way better. So the first one, number 9, says the sum of a number and 10. And anytime it says a number, on here I'm going to write n. So a number, I'm going to say is n. It could be any variable you want, any letter, but just if it says a number, since the number starts with n, I'm going to write an n. So the sum means addition of a number and 10. So we just say a number, n, plus 10. Then we say in number 10, it says 15 less, and less is going to mean subtraction, than k. And when I see less than, that means that the 15 has to go after the minus sign. So I'm going to have k and then minus 15. The next one, the product of 18 and q. Product means multiplication. So I'm just going to multiply 18 and q, and remember, when I put a variable right next to a number, that means multiply, so I don't need to put a multiplication sign in between. 6 more than twice m. So 6 more means plus. Twice means 2 times that. So multiplication. So I'm going to start with the twice m. And that's going to look like 2m, because there's a variable. If I stick a 2 next to it, it means they're multiplied. And then 6 more, I'm going to add on at the end. 6 more. The next one, 8 increased by, is going to mean addition. 3 times a number, times is going to mean multiplication. So 8 increased by 8 plus 3 times a number, n. So 3n, 3 times n. I don't have to put the multiplication in between. Number 14, the difference of 17 and 5 times a number. So the difference is going to mean subtraction. Times is going to mean multiplication. So whenever I see the difference, I need to write the numbers they give me in the order they give them to me. So they give them to me 17 and then 5, and then it says times a number, so I'm going to stick an n next to it. And difference means subtraction. So 17 minus 5n. And that would be different if I wrote 5n minus 17. Number 15, the product of 2 and the second power of y. So product means I'm going to multiply the two things they give me. And the second power of y means y squared. So I'm going to multiply the 2 and the y squared to give me a product. So I just end up with 2y squared. I don't need to write multiplication in between because when they're next to each other, that's what that means. And then the last one on this page, number 16, says 9 less. Less means subtraction. Then g to the 4th power. So I'm going to, again, reverse. I'm going to put my g first. G to the fourth. Sorry, it's getting a little off here. I'll have to reorient my board. G to the fourth, and then minus 9. Alright, bear with me while I reorient. So we can continue on with the back side of the worksheet. Okay. There we go. The back side of the worksheet again, we need to write the verbal expression for the algebraic expression. So we're going from math to words. So the first one we have up is 23F. And 23F, when they're next to each other, means a product. They're being multiplied. So you can just write the product of 23 and F. I'm going to switch colors, that's a little difficult to see. And then number 2, we have 7 and the third power. So we could say 7 to the third power, but remember that when it's the third power, we use special words like cubed. So we would just say 7 cubed. Number 3, we have a couple of things going on. We have 5 and m squared being multiplied, and then we're adding that on to 2. So I think I'm going to call this one the product of 5 and m squared increased by 2, because I'm going to treat this as an increased by. So whoops. Call it, I'm actually going to say 2 more. That seems to flow better in my mind. So I'm going to say 2 more than the product of 5 and m squared. Okay. And then the next one I'm going to do very similarly, and I'm going to say 10 less than with this minus sign. I'm going to say 10 less than the product of 4 and d cubed. And the reason that in number 3 I kind of went back and went against what I said is, like I said before, you want to make sure that it makes sense what you're doing. So when I was going to say 5, the product of 5 and m squared increased by 2, they might have gotten confused and thought that this is what it would have meant. The product of 5 and m squared increased by 2. And we don't want people to get confused, so that's why I went back and changed, because it seemed like the way that I wrote it now is a little bit more clear, and it wouldn't get people thinking that this is what I meant. A dot means multiply. They could have just as easily put x cubed right next to y to the 4th, and it would have been fine. But if we're multiplying, we're going to call that a product. So I'm going to say this is the product of x cubed and y to the 4th. The next one, a couple of different ways you could do that. I think I'm going to write it just as it's written. So I'm going to say b squared minus 3 times c cubed. I think that's the clearest way to put it. So b squared minus 3 times c cubed. And again, I could have just as easily said minus the product of 3 times, or excuse me, minus the product of 3 and c cubed, and that would have made just as much sense as well. This one's a little bit tricky. When you have a fraction, or when something is over another thing, that means division. So another way of writing division is the word quotient. So it's kind of the opposite of product. So in this case, I could say the quotient of k to the 5th power and 6. I could have also written k to the 5th power divided by 6. That would have been just fine as well. And for the last one on this section, we have 4 times n squared divided by 7. I could write it just the way I said it there. I could say the product of 4 and n squared divided by 7. I think I'm going to do it the first way, which is just to read it as it is. So 4 times n squared divided by 7. Okay. Next page. All right, and again, this is the way I like to do it. It seems easier to me to go this direction than the other ones. So we're going to go from words into a math expression. So from verbal expression to an algebraic expression. So the difference of 10 and u, anytime you see the word difference, you're going to write the numbers or the variables in the order they give you. And difference means subtraction. So I'm going to put a subtraction in between. The sum of 18 and a number, and remember that I'm going to take a number in here to mean n. Again, you could have it be any letter that you chose or symbol that you chose. I'm just going to say n because number starts with n. So the sum, I'm going to write 18 plus, because that's what sum means, is plus a number which I'm calling n. The product means multiplication, 33 and j, and remember I do not need to write multiplication in between if it's a number and a variable. So I can just write 33j. 74 increased by means plus, and then 3 times y means multiplication. So 74 plus, and then I'm going to multiply 3 and y, and to write that I'm just going to put them next to each other. 13 says 15 decreased by, opposite of increased by in the last problem, so we have minus, twice a number. Twice means I'm going to multiply it by 2, so 2 times that number. So I'm going to say 15 minus 2 times a number n. And I don't need to put the multiplication sign in between, it's implied. 91 more than the square of a number. More means I'm going to add 91 onto whatever I have, and the square of a number is going to be n squared. So I'm going to have n squared, and then I want 91 more, which means I add on 91 at the end. And the last one, 3/4 the square of b. And if it ever says of or just a fraction and then something, that means they're being multiplied. So that right in here is an implied multiplication. So I can just write the fraction 3/4 times the square of b. So times b squared. And since it's a number and a letter, it's implied when they're right next to each other that they're being multiplied. All right. 2 more problems, the happy word problems. So we have a used bookstore sells paperback fiction books in excellent condition. So excellent condition are $2.50. Sorry about that. And in fair condition, for 50 cents each. Write an expression for buying X excellent condition paperbacks and F fair condition paperbacks. So X is going to cost you $2.50 each, and F is going to cost you 50 cents each. So it's going to be however many X books you buy times $2.50 plus however many F books you buy times 50 cents. So my algebraic expression for this one is going to be 250x. That stands for however many excellent condition books you buy, plus 50 cents times F. So for instance, if I bought 2 excellent and 1 fair condition book, I could put those in there and my cost would be $2.50 times 2 plus 50 cents times 1, and that would mean that my total bill would be $5.50. And the last problem. The surface area of the side of a right cylinder can be found by multiplying twice pi by the radius. So we're multiplying the radius and then also multiplying the height. So pretty much I can pick straight out of there that I need twice pi, that means 2 times pi. Then I'm going to multiply that by the radius. And lastly, I'm going to multiply that by the height. So the surface area of a right cylinder can be found by multiplying 2 times pi times the radius times the height, or 2 pi r h. And that is the end of this video. Please feel free to watch it again.